So we're finding inverses. We're using algebra to find inverses, then we're graphing them, checking that they are inverses, and finding domains and ranges. This is a one-to-one function. It is one-to-one on its domain, which is actually all reals. Range is all reals, and so this one's going to be like the last one. Alright, first, we'll rewrite it as y equals instead of f of x equals, and then flip my x and my y. So x equals 4y cubed plus 1. And that's the inverse, and now we solve for the new y, which will give us our inverse. So first thing, move the negative 1 over, so x minus 1 equals 4y cubed. Divide by 4. And then to get rid of the cubed, which is why we practiced the powers in the previous section, is I take the cube root, which is a power 1/3. So you can leave a power 1/3, or you could change to the cube root. On this side I get y. Over here, again, it's up to you. You can either leave it. I actually think it's just as easy to leave it the cube 1/3 power, but if you prefer the root, it's the exact same thing. Alright, so either of those will work. And so my inverse function, right, that's my inverse. The cube root of x minus 1 over 4. Alright, now the graphing and the domain and range, right? So my inverse, just so I have it. And again, I like the fractional power, so I'm going to write it as the fractional power. If you prefer the root, write the root. They're the same, doesn't matter. For all of these, the domain and the ranges, and you'll see for both, infinity to negative infinity. So when I go to graph it, you will see that. Alright, so the graphs. Alright, so these graphs are a little more complex, so I'm going to encourage you, if you need to, you have a graphing calculator, use your graphing calculator to find some points, and remember the points should be reflection. So I'm going to draw f of x using, so I'm going to start with my f of x function, and graph it using a few points, and kind of my calculator to make sure I get points that actually make sense. So if you graph it on the calculator, it should have an S shape. Right, it should go up, but if I plug in 0, it's up here at 0, 1. So that's the first one, 0, 1. And then I'll probably plug in 1, and that puts me up here at 5, so 1, 5 is another point. And then negative 1 is the other one. I'm going to plug in negative 1, puts me down here at negative 4. I'm sorry, negative 3. Alright, so I plug in negative 1, I get negative 4, plus 1, which puts me down at negative 3. So make sure I got the right point. Negative 1, negative 3 would be the right point. Alright, so now my shape. So again, it's got this S shape, but if you look on your calculator, it's got an S shape. So it's coming up fairly fast. It's got a flattening out shape here, and then it shoots up there pretty fast. Right, there's my original. Now I'm going to draw my inverse. Alright, so this is the inverse I'm going to use. And I use my calculator, and then I'm going to plug in, so remember, it should have the flip of this, so I'm going to plug in 5 and negative 3. I might mark off my points so I have them. Alright, I'm going to graph it in red. And so if I plug in 1, it should give me out 0, and it does. When I plug 1 in, this zeroes out, and so I do get the point here at 1, 0. Alright, then I plug in 5, right? Because I'm going to make sure that I get the flip of this. So when I plug 5 into this original function, this inverse function, I'm plugging it in here. So when I plug 5 in, I am going to get 1 out, because it's going to be 5 minus 1, which is 4. 4 divided by 4 gives me 1, and so it is going to give me out 1. And so it does give me out 5, 1. And if I plug in negative 3, I should get out negative 1, and I do. If I plug in negative 3, it's going to give me negative 4. divide by 4, which gives me -1, and so I do get a -1. So -3, -1. And so it has that opposite shape. So again, it's coming up fairly fast. It hits there, makes a kind of a kink shape, an S shape, and shoots out in the other direction. So and your calculator should reflect that, should show that. Alright, so there is the graph of both of them. It does check, right? My points on one were the flip of the points on the other. It's just a little messier when we go to graph it, but you can graph them both on your graphing calculator and use your graphing calculator to help you out. Alright, we'll stop there, and we'll pick up the last example, which again is even more complex, which I would encourage you to use your graphing calculator on the next example when we get to the graphing part. The check, and the graph really is just a check to make sure you got the right picture out, the right function out.